This short video is going to introduce the research project Math for the Sahel. What is the Sahel? You can see this orange band here. I should point out that I'll be talking about Cameroon, which is this country right here. The Sahel intrudes into the northern part of Cameroon. So the Sahel borders the Sahara Desert to the south. It's about 4 times as big as Texas. Rainfall is very little, similar to Amarillo. Population is about twice that of Texas. There are a number of challenges in this region. One is it's economically underdeveloped. 2, the environment is very fragile. So the big challenge is to develop the economy and improve people's living level without degrading the environment. In northern Cameroon, there is the Higher Institute of the Sahel. It's located in Maroua. It's established in 2008. Here are the focus areas: renewable energy, product development, information and telecommunications, water resource management, developmental social science, and environmental science. So all of these go into developing the Sahelian region. I will be teaching in the Department of Information and Telecommunications. You should think of that as the computer science department. I will be teaching a graduate math modeling class. This will be offered in the Department of Computer Science. The student's math level is not so clear. It's probably about the same thing as TMUC grad students. Students are to become technical professionals, including engineers, managers, decision makers in the government. So they will have important positions. The goal of this class is to enable students to learn mathematical tools to tackle practical issues related to Sahel management and development. By the way, these pictures are pictures of some of my students in Chad. I taught there in 2004. So the development strategy for the curriculum is to develop a collection of relevant mathematical models at various levels, including simple examples that can be used to introduce the math, pseudocode that can be read by programmers, and state-of-the-art examples that show the up-to-date application of these mathematical models. Now, by relevant, I mean that the models should relate to development and resource management, especially in the Sahelian environment. So that's going to be the challenge, is to find these models. The eventual goal is to make a book, perhaps entitled Math Modeling for the Developing World. So let me give you an idea of what types of models we might be looking at. Linear and integer programming. This is good, say, for scheduling or for allocation of resources. This has revolutionized applied mathematics in the United States. It's one of the reasons why American economy is so efficient. Also network flow, network having to do with transportation networks or communication networks. I also would like to introduce probabilistic models, Markov chains, which are based on repeated applications of matrices, network models for economic development, and agent-based models. All right. So these are some idea of what we're going to be looking at. There will be other models, perhaps differential equation models also, but that's the principal focus I'd like to look at. Okay, so here's the breakdown of tasks. First, we'll have to search the literature. We'll need to find appropriate math models. Some of these will be very basic. We can look at textbooks. Others will be more research-oriented. Now, once we find models, we should categorize them. So you'll write down some different categories. Say type of model, level of sophistication, the source, and whether it's proprietary or not. So I'll develop a spreadsheet that you can fill out once you find these different resources. So once we've created a list of different applications, we'll decide which models to focus on. There will be some background theory necessary, so we'll find some free online materials that will give us background material to linear algebra, differential equations, linear programming, and so on. There's plenty of free material out there. Once we've decided which models to focus on, then we'll do the write-up. We'll develop content templates so that you can take up application and then very simply categorize the information. So we want to do kind of a cookie-cutter approach where you don't treat every different application differently. We're going to try to make the write-ups consistent for all the different applications. We really want to emphasize simplicity over depth. I want to make sure that students understand and not be too overly sophisticated. I plan to use LaTeX, which is a high-quality scientific word processor. The final challenge is to translate into French. For this, we'll use some automatic translation software. So, if you get involved in this process, you'll have exposure to two very important types of software: scientific word processing, or LaTeX, and automatic translation. Now, you might say this is computer science but not math, but really modern math goes hand in hand with computer science. You can't isolate one from the other. All right, how to get involved? You would either register for a topics class or a thesis. The class will run in both summer and fall. In summer, it will be done online with one-on-one Skype conferences where I'll supervise your work and help you get over any obstacles, and we'll discuss progress and so on. You'll probably have once-a-week conference. In the fall, I'd like to have a once-per-week group meeting. That will be more the putting together the materials, that'll be later stage. The summer will be more groundbreaking work. If you do take the thesis, you'll have to enroll in both terms. And let me know if you're interested. So, thanks for watching.